A survey found that in 1995, the average hotel room rate in New Orleans was $88.92, and the average room rate in Phoenix was $80.61. Let's assume that the data was collected from 2 samples of 50 hotels each, and that the population standard deviations are known to be 5.62 and 4.83 respectively. At alpha equal 1%, can it be concluded that there is a significant difference in the room rates? Okay, so how we're going to start this is we will look and see what are we concluding. Can it be concluded that there is a significant difference in the room rates? Well, if there's a significant difference in the room rates, then mu1 would not be equal to mu2. And that would mean that mu1 minus mu2 was not equal to 0. Now, this claim does not contain equality. It specifically has the not equal to symbol. So the claim mu1 minus mu2 not equal to 0, that will become the alternative hypothesis, because the null hypothesis must contain equality. From there, we can state the significance level of the test. We were told at the 1% significance level, so alpha is equal to 0.01. And we will also need to circle the type of test. Well, the test will come from the null hypothesis. From the alternative hypothesis. The alternative hypothesis is the claim. It contains the not equal to, and this means we'll be performing a two-tailed test. Now let's determine the sampling distribution. So we have a few requirements. Sigma is known, so that's a good indicator. We'll be using the Z-test, but we have to make sure that the normalcy properties are satisfied. We were told that n for both cases, for both samples, was 50. That is greater than 30, which is the requirement that we need to be able to use the Z-test. So we've met the requirements, and now we will use the 2-sample Z-test. So we're going to need to be able to determine the critical value for the rejection region. Now remember, alpha is given as 0.01, so alpha over 2 is going to be equal to, because we're looking for a two-tailed test, 0.005. So when we do this over here, 0.005 should be in this region, and 0.005 should be on the left. So now we just need to find these critical values. So to do that, we'll use the inverse norm function on our calculator. We'll find the inverse norm for 0.005, and when you put this in, you'll get negative 2.58. Okay? So that corresponds to here, and then by symmetry, the right-hand side will be 2.58. All right, now let's find our test statistic. So to do that, Z must be equal to, and I've written a few things down for us to reference here. So let's let New Orleans be the first one. So their average rate was 88.92, and then in Phoenix, the average rate was 80.61. Now from there, we're going to have to subtract off what we expected, mu1 minus mu2. Well, that comes from the null hypothesis, and we said that from the null hypothesis, mu1 minus mu2 would be equal to 0. Then we have to take the square roots of the first standard deviation, so 5.262 squared, divided by n1, so the number in that sample was 50. And then we do the same thing for Phoenix, so its standard deviation was 4.83. Square that, there was 50 in its sample as well. Okay, So I would do these step by step. Subtract off the numerator, and the numerator should be 8.31. Work underneath the radical, find that value and take the square root of it. And when you do, you should come up with 1.04798. And when you divide these two, we get a test value of 7.93. Okay, so that's all the way in here, right? So this is very clearly in the rejection region. We could calculate the probability associated with this. Now you'll also need the negative because this is the two-tailed test, right? So 7.93, we could also calculate this probability. Okay, so that's what we'll do in the second step. So we can either calculate, we need to find the probability in one tail and then double that. So we either need to take 2 times the probability that z is less than the negative value, negative 7.93. We could also calculate the probability of the upper tail, z being greater than 7.93. These are going to be the same by symmetry. And when you do this, what you'll get is this probability is effectively 0. And so the probability or p-value associated with this test is 0. And that will allow us to make the conclusion. And the conclusion is we are going to reject h sub 0. You can do that based upon the p-value, that 0 is less than alpha, 0.01, or that our test statistic, 7.93, is greater than our critical value of 2.58. That is, it is inside the rejection region. And now that we've finished the test, then we can translate our conclusion into a formal sentence. At the 1% significance level, there is enough evidence to support the claim that there is a significant difference in the hotel room prices for New Orleans and Phoenix. Now we could also look at the confidence interval associated with this. We could construct the 95% confidence interval estimate of the difference between the two population averages. To do it, we'd have to go to stats and then tests in the 2SampZT interval. Now when you get here, there's 2 options. You can either enter data or you can enter stats. Make sure you're on the highlighting of stats for the inputs. I've just referenced the New Orleans and Phoenix values for us. You'll need to input those on the screen once you're in the stats portion of this. And what you should come up with is on the low bound, 6.26 will be less than mu1 minus mu2, which should be less than $10.36. And then we could ask the question, what does the confidence interval suggest about the claim that the average hotel room rate in New Orleans and Phoenix are significantly different? So this will take a little bit of reasoning here. What this is saying is we look at the null hypothesis, and the null hypothesis said that there was no difference. That is, that mu1 minus mu2 would be equal to 0. And since 0 is not in the interval, our confidence interval, this 6.26 and 10.36, 0 is not in there. If it was reasonable that there was no difference, then 0 should be in that interval. But the null hypothesis must be wrong, and we can conclude that there is sufficient evidence to support the claim that ... just as we wrote before.